Hey geometry, let's get right to work. So to show that two segments are congruent, we're going to use the distance formula. Now we usually use a squared plus b squared equals c squared for this. To show we're parallel or perpendicular, we use our slope formula. Parallel is same, perpendicular is flip the fraction, change the sign. Finally, bisect each other. We use the midpoint formula to see where that half is. So we're going to dive right into this bottom question. This will be your notes for today. We'll use this as the example for tomorrow. So we are going to classify a quadrilateral in the coordinate plane. To do this, our first step is always to graph the actual quadrilateral. So we have quadrilateral BOAT, B-O-A-T, negative 4, comma 1 is B, 3, comma 0 is O, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7 is A, and finally negative 2, 1, 2, 3, 4, 5, 6 is T. Now you can either sketch this next part or use a straight edge. I'm going to use a straight edge. And we have a beautiful little line right there. So to classify this, we're going to look. All right, with a little movie magic. We're looking for these three things, and I want you guys to draw the diagonals here. Feel free to pause the video if you need to while you're doing this. So we're going to find the midpoint length and slope of the diagonals and use that to see what kind of shape this is. So the first thing we're going to do is find the midpoint. Now obviously you can find the midpoint graphically, and you can see it hits about here. Let's verify that algebraically with the formulas from above. So the midpoint formula has x plus x over 2, comma y plus y over 2. So if we use and find the midpoint of OT, the midpoint of OT would be 3 plus negative 2 divided by 2, comma, and then the y values. 0 plus 1, 2, 3, 4, 5, 6 divided by 2, and we get the midpoint of OT is 1/2, comma, negative 3, which is exactly what we would expect it to be. If we also find the midpoint of BA, we would say that would be the negative 4, the x value, plus 5, the x value, divided by 2, comma, 1 plus negative 7 over 2, and this would end up being 1/2, comma, negative 3 over 2. Because these are the same exact midpoint, therefore, diagonals bisect each other. All right, so we know it's at least a parallelogram. For length, we're going to use the Pythagorean theorem. So here we can see that OT goes over 1, 2, 3, 4, 5, and up 1, 2, 3, 4, 5, 6. If we solve this, we get that C is equal to the square root of 61. If we do the same thing for BA, the lengths we're going to see in our triangle are going to be 9 squared plus 8 squared equals C squared. If I do the same exact thing here, we end up getting the square root of 146 equals C. Those are not the same value. Therefore, diagonals are not congruent. So it's definitely not a rectangle or a square. Finally, slope. Looking here, OT is up 6/5. Up 6/5. BA is down 8/9. You can make that triangle just like we practiced in class. So down 8/9. Now, these slopes are not opposite reciprocals. Not opposite reciprocals. So therefore, diagonals are not perpendicular. So, if diagonals bisect each other, they are not congruent, and they are not perpendicular, it has to be a parallelogram. It can't be a rectangle, and it can't be a rhombus. Today in class, we're going to see, okay, if we don't want to look at the diagonals, what else can we look at to prove these true? So, looking forward to seeing you in the class. Again, bring your calculator, ready to go.